Welcome to the session. Today in this session we will see about DC motor. So what is meant by DC motor? So DC motor, it is a device which is going to convert an electrical energy into mechanical energy. In the previous unit we have seen that a DC generator, so which is going to convert an mechanical energy into electrical energy. So here the DC motor will do the reverse function of DC generator. Means it is going to utilize the electrical energy and convert into mechanical energy. And the EMF generated in the DC motor, we call it as back EMF. So why it is called as back EMF or counter EMF? We'll see about it. So we can see that when a supply is given to the DC motor, the armature starts rotating. The rotating armature conductors cuts the stationary magnetic flux produced by the poles. So as you seen in the DC generator diagram, so that where the flux is generated, so that is being cut by the rotating armature conductors, and when it is cut by the armature, an EMF is induced according to an Faraday's law. So that EMF we call it as back EMF. Why it is called as back EMF? Because the induced EMF acts in opposite direction to the applied voltage, and hence it is called as back EMF. So for example, if I take a shunt motor, here you can see that voltage is given to the motor. So whenever the voltage is given, so the armature start rotates and EMF is induced. So in the circuit you can see that the direction of an voltage is in upward direction, whereas the induced EMF is in downward direction. So since the generated EMF is in opposite direction to the applied voltage, it is called as back EMF. And the equation for back EMF will remain same as in DC generator. Means there is E is given by Z pi into Z pi n in divided by 60 into P by A. So similarly for back EMF, the EMF equation will remain same. Next we see about the significance of back EMF. So this is the circuit I have taken. As the armature rotates, back EMF which opposes the applied voltage is induced. The applied voltage has to force the current through the armature against the back EMF. The electrical work in overcoming the opposition is converted into mechanical energy developed in the armature. Therefore, the energy conversion in a DC motor is only possible due to the production of back EMF. So here you can see that whatever the back EMF is generated, it is going to oppose the applied voltage. So it has to overcome the applied voltage, means the applied voltage has to force the current through the armature against the back EMF. So here some amount of work has to be done in order to supply the current. So that work we call it as electrical work done, and it is also called as mechanical energy developed in the armature. So here you can see that the electrical work done in overcoming the opposition is converted into mechanical energy developed in armature. So this electric work done is occurred due to the existence of what? Back EMF. So this is the one of the significance of back EMF. So there is a generation of mechanical energy that is due to the effect of back EMF. And second point, the net voltage across the armature circuit. So by using this circuit, you can see that it is given by V minus EB, where V is the applied voltage and EB is the back EMF. If RA is the armature resistance, then the current across the armature is given by V minus EB divided by RA. So from the equation here, the applied voltage and the armature resistance are fixed. So the value of EB will determine the current drawn by the motor. For example, if the speed of the motor is high, then back EMF is large, and hence the motor will draw less armature current. So here you can see that if the motor is rotating at high speed, then EMF, back EMF will be very large, and the motor will draw a very less amount of armature current. And in the other hand, if the speed of the motor is low, then the back EMF is small, and hence the motor will draw large amount of armature current. So what we can observe that whenever the motor is running at high speed, the current drawn will be less, and when it is rotating at less speed, the current will be more. So hence the presence of back EMF makes the DC motor a self-regulating machine. Means it makes the motor to draw as much armature current as is just sufficient to develop the torque required by the load. Means the motor itself will regulate the back EMF so that it can develop required torque for the load. Means based upon the load, the motor is going to self-regulate itself to develop the required torque for the load. So means based upon the load, the motor itself starts self-regulating to produce the required torque, and that is attained by regulating the speed of the motor. Next one is the voltage equation of motor. So this concept we will see in types of an DC motor. So now we'll discuss the we'll see about the torque equation of an DC motor. So the general meaning of torque is a twisting force or the rotating force. So what it means? So torque is the turning moment of force about an axis. So means it is a twisting force produced about its own axis, and it is given by the product of force and the radius of the armature. So here I have considered the armature core. So consider the armature of the DC motor, which is having a radius R, and let F be the force acting tangential to its surface. So according to the definition, the torque is given by TA equals F into R. So it is always measured in Newton meter. Next, the work done in one revolution of armature. So as the armature starts rotating, just I have considered only one revolution. So we know the general definition of work. It is given by force into distance or displacement. So here the distance covered in only one revolution. Since I have considered for only one revolution, and it is a the armature is in circular, so I have to consider the distance in terms of an circumference. Therefore, the work equals force into distance, and here it is given by F into 2 pi r, as it is a distance is covered in terms of an circumference. So on replacing F into R into 2 pi, so F into R can be replaced with TA. So on adjusting these terms, so F into R, we can see that that is the armature torque. So we get the work equals W equals 2 pi into TA. Next point, the power developed by the armature. So the general formula for power is given by the amount of work done for a given time. So here the work done in 1 second means the work done I have already seen, that is W equals 2 pi into TA, and the time taken. So what is the time taken to complete one revolution? So we have seen in the EMF equation of a DC generator. So that is given by 60 by N. So the same equation I have taken here. The time taken for one revolution is given by 60 by N. So on substituting the work done per time taken, so 2 pi into Ta divided by 60 by n. So on adjusting the terms, we get P equals 2 pi n into Ta divided by 60. So this equation is also used in while solving the problems. So directly the power, if the power is given, we can use this equation, that is P equals 2 pi n into Ta divided by 60. So there you can find out the value of armature torque. So we have seen about the torque, that is Ta equals armature torque equals F into R, and work is given by 2 pi into Ta, and the power is given by 2 pi n into Ta divided by 60. And next one is the power developed in the armature. So in the DC generator, we have seen that the power developed across the armature is given by P equals Eb into Ia. So considering that power, so take it as equation 2. So let the power developed by the armature in the previous, we take it as equation 1. So on equating equation 1 and 2, we get 2 pi n Ta divided by 60 equals Eb into Ia. And we know the equation for back EMF. So that is given by Eb equals, so Eb equals Z pi n divided by 60 into P by A, same as your generated EMF. So on equating those two, solve for the torque equation, means to find armature torque. So on rearranging the terms, we get Z pi I A divided by 2 pi into P by A. So this is the equation for armature torque. If I solve for 2 pi, I get Ta equals 0.159 Z pi Ia into P by A. So the armature torque, it is also called as the gross torque developed by the armature. So this is the torque equation of an DC motor. So next we will see the different types of an torque. So the first one is, as we have seen that is the gross torque or armature torque. And next, the above equation gives the gross torque developed by the armature, which includes the iron losses and the mechanical losses of the motor. So the actual torque available at the shaft to do useful work is known as shaft torque. So on removing the losses, we get a useful work. So that torque we call it as shaft torque, means the torque which is used at the shaft, so that we call it as shaft torque, and it is always less than the armature torque, because the torque which is occurred due to the losses, so that we have to remove. So means torque due to losses, those losses are iron losses and mechanical losses. So the total shaft torque is always less than Ta. So TSH equals Ta minus TL. So where TSH is shaft torque and Ta is armature torque. And as I told, the TL is torque due to losses. So that is iron losses and mechanical losses. So if we want to calculate the useful torque, it is given by, first I consider the output of the motor, means the power of the motor. So here you have seen the equation, it is given by 2 pi n Ta divided by 60. So if I want to calculate the shaft torque, in the place of Ta you substitute TSH. Therefore output of the motor equals 2 pi n TSH divided by 60. So if I want to calculate the TSH, therefore TSH equals output of the motor in watts divided by 2 pi n divided by 60. So and usually the output of the motor is given in HP, and the 1 HP is always equals to 735.5. Therefore TSH is equals to output in HP into 735.5 divided by 2 pi n divided by 60. So this is the equation for shaft torque. So by using this, even you can calculate the armature torque, that is Ta equals, so output of the motor in HP into 735.5 divided by 2 pi n divided by 60. So this is all about DC motors. So in this session we have seen about the DC motor introduction, back EMF, back EMF significance, and the torque equation. So you go through this video session. So if you have any doubts, you can interact in group. Thank you.